Again, we see that we can take the rate function, and by knowing the relationship between a linear rate function and a quadratic depth function, we can determine a depth function up to the parameter c. And we'll deal with the parameter c more specifically later. The process that we followed, we see that we can start with a depth function and take the derivative of that function to get the rate function. We've got the formula for the derivative of a quadratic depth function. We could also start with the rate function and go in the other direction, a direction opposite to the derivative, sometimes called an antiderivative, to find a depth function. Another word for this process is to find the integral of the rate function, or find an integral of the rate function. We'll be more specific about why I say an integral instead of the integral, but it comes down to the fact that c could have many different values, so there are many different possible integrals. We see that when we start with a quadratic depth function, we end up with a linear rate function. So if we have a linear rate function, it must have come from some quadratic depth function. This is the essence of the calculus. We can find derivatives to go from something like a depth function to a rate function, or from any amount function to an associated rate function. If we know the rate function, we can pull it back by this integration process into the depth function. We call this an integration process because the rate function tells us pretty accurately how much depth change there is over short periods of time. If the rate function is linear, it in fact tells us how much depth change there is totally. But we can think of the rate function as something by which we can calculate differences in depth changes over short intervals of time. If we then put those small depth increments that come from the rate function over short periods of time together, that means we integrate them. To integrate is to put together. So we put together the knowledge that we get from short intervals in the rate function to obtain a depth function. We'll see much more about this idea as we go through the course.